Welcome to the Dropson webinar. This webinar has been designed to teach technicians, installers or engineer studies regarding the improvements in the fight against limescale in hot and cold water circuits. Here we will present a new technology, the new generation Dropson anti-scaling systems. EMI technology is based on the research work by CNRS, National Center for Scientific Investigation, and other international organizations. Even though Dropson is a new generation anti-scaling system, our company has over 10 years' experience in the development and commercialization of our products. Our production factory is based in Spain, the main reason being that Spain currently offers competitive bonuses and being as it is a part of the EEC, allows a greater sales force for the export market. Our technology offers an alternative solution to traditional water softeners, with numerous advantages. Energy saving. Dropson prevents lime deposit formation and ensures the optimal conditions for heat exchange between the primary and secondary circuits. This will result in a higher control over energy consumption. Simply observing this table, one can realize that considering the limescale level of an element that gives out heat, one can see the exponential curve of energy consumption increase. Our technology allows control over production shutdowns and preserves the longevity of the installation. Treating the installation against limescale implies reducing sanitary risks. A clean installation without limescale would mean decreasing Legionnaire's disease biotype. Next, we will undertake a progressive explanation so we may learn from simple audiovisual stages the mechanisms involved in the physical treatment of water. We will start by better understanding the water molecule.
The water molecule. The water molecule is formed by two hydrogen atoms, bonded to a single oxygen atom. Its chemical formula is H2O. H is for the hydrogen atoms, and O for the oxygen atom. The electrical charges of the molecule are distributed asymmetrically. On one side, a negative charge appears on the oxygen side. This is the negative pole of the molecule. On the other side, a positive charge appears on the hydrogen side. This is the positive pole of the molecule. Water is a polar molecule. As positive and negative zones attract each other, the molecules join in the water by means of bonds called hydrogen bonds. The liquid state. In the liquid state, water molecules join and separate constantly. These molecules, that are in perpetual movement, will flow according to the temperature. At higher temperature, there will be an increase in movement. Lower temperatures will decrease movement. The solid state. Below 0 degrees Celsius, the movement of the molecules stabilizes, forming a rigid structure. Thus, water varies to a solid state, forming ice. Gaseous state. Once over 100 degrees Celsius, the water molecules move at such speed that it is impossible for them to bond. Water becomes gaseous.
What should we retain? The water molecule is formed by an oxygen atom and two hydrogen atoms. The water molecule is bipolar, with a negative electrical charge on the oxygen side and a positive electrical charge on the hydrogen side. Opposite charges attract each other, negative to positive. Water molecules are in constant movement. The higher the temperature, the more they vibrate. With lower temperature, these vibrations are reduced. Solvation. If you have memorized correctly the characteristics of the water molecule, one can easily understand solvation. Solvation is the name of the dissolution phenomenon. We have all seen that common table salt dissolve in water. But how do the salt crystals dissolve in water? Which are the solvation mechanisms? This video is extremely important to understand the physical treatments.
In order to understand better the physical treatment of water, it is important to comprehend a very simple question. Why does table salt dissolve in water? To understand the solvation of table salt, it is necessary to previously study the electrical charges of different molecules. The water molecule is bipolar. It has a positive side and a negative side. The molecule that forms table salt is composed of sodium chloride. Therefore, its molecule consists of a sodium ion, positively charged, and a chloride ion, with a negative charge. Water molecules will position to the positive charge to extract the chlorine ions. Similarly, they will position to the negative charge to extract the sodium ions of positive charge. The water molecules will position differently depending on the electrical charge and the composite to dissolve. They will surround the calcium and sodium ions to dissociate them, thus forming solvation spheres. These solvation cells trap the chlorides and the sodium, impeding further merging. This is how the water molecules extract the sodium and chloride ions from the salt crystals and dissolve them.
What should we retain? The water molecule is a dissolvent capable of dissolving certain molecules. For example, water will separate the sodium and chlorine ions that form table salt. Water molecules organize forming solvation spheres. Remember the concept of solvation sphere. The image of the water molecules organized in a circle to separate the elements and prevent them from joining again. How is limescale formed? Once the behavior of the water molecule and the concept of solvation are fully understood, thanks to this video, we will easily understand how limescale is formed in the hot water installations.
Upon looking at the chemical composition of mineral waters, we can confirm the presence of calcium and bicarbonates, whose chemical formulas are Ca and HCO3. Lime derives from these two elements. Tap water, as well as bottled water, contain calcium ions and dissolve bicarbonates. Calcium ions are positively charged. The water molecules that surround them will position to the negative charge pole, forming solvation cells. Bicarbonate ions are negatively charged. Water molecules surrounding these will position to the positive charge pole. The solvation spheres, composed of water molecules, maintain these two components dissolved in water and impedes bonding. By providing energy to the water with an electrical resistance, for example, the water temperature will increase. It has been observed that water molecules increase in agitation upon elevating the temperature. The molecules will agitate strongly due to the proximity of the resistance. Thanks to this vibratory effect, the structures of these water molecules will break like simple soap bubbles. Thus, the positively charged calcium ions are freed, as are the negatively charged bicarbonate ions. As opposite charges attract, the calcium and bicarbonate ions will adhere to the heating elements, forming calcium carbonate. This is how lime forms on an electrical resistance.
What should we retain? Limescale is formed by calcium and bicarbonate ions dissolved in the main water supply. In this image, we can see how the water molecules create solvation spheres to separate the calcium and bicarbonate ions. Under heat, the water molecules vibrate, and by this oscillatory effect, they break. Free from their solvation spheres, the calcium ions, positive, and the bicarbonate ions, negative, will attract each other to form upon a heated support calcium carbonate, also known as limescale. Some frequently asked questions. Why then can we find limescale in the cold water circuits? The explanation is that when water travels through certain bends or narrow places in a cold water circuit, the solvation spheres may also break and release the calcium and bicarbonate ions to form limescale. We will now see how the physical treatments act upon water. It is hard to understand how an electric or magnetic field can affect water. Therefore, we propose to observe certain physical experiments done on water.
How physical treatments work. Above all, we will present two simple experiments to undertake. Experiment number 1. Electrostatic fields and their effects on water. If we rub a plastic ruler with a cloth and approach it to a trickle of water, we can see that the water changes trajectory. What has happened? Rubbing the ruler charges it with negatively charged static electricity. Since opposite electrical charges attract each other, approaching the ruler to the trickle will reorient the positive charge of the water molecule, and these will be attracted towards the ruler. This simple experiment proves the effect an electrostatic field has upon water molecules. We can observe a second experiment involving magnetic fields. We place a drop of water on a transparent support, impregnated with a hydrophobic treatment. This treatment eliminates surface friction, and the drop of water can displace freely. If we approach a powerful magnet to the drop of water, it will be repelled. This experiment proves the effect of magnetic fields on water molecules.
What should we retain? Rubbing a plastic ruler with a cloth will charge it with static. The ruler with a negative charge will attract the positive side of the water molecule and will change the water trickle's trajectory. We have seen that a magnetic field can act on a drop placed upon a hydrophobic surface that eliminates friction. The magnetic field affects the water drop, repelling it. The preventive effect. We will show you how, with the aid of an electrical or magnetic field, it is possible to create an anti-scaling effect.
As we had previously seen, it is possible to disrupt the water molecule by means of an electrical or magnetic field. We will now observe how the elements that cause lime react in the presence of fields or pulses, magnetic or electric. The elements that derive in lime formation are calcium ions and bicarbonate ions dissolved in water. Calcium ions are positively charged. The molecules will position to the negative charge to form a solvation cell. Bicarbonate ions are negatively charged. The water molecules that surround them will position to the positive charge. The solvation spheres formed by the water molecules maintain both elements dissolved in the water and impede convergence. If we expose these elements to an electrical or magnetic field at a specific frequency, the water molecules will vibrate rapidly. As a consequence of this vibration, the structure of the water molecules that form the solvation cells will explode, releasing positively charged calcium ions and negatively charged bicarbonate ions. As opposite charges attract each other, the calcium ions will converge with the bicarbonate ions to form calcium carbonate microcrystals suspended in the water. It is in this manner that physical systems operate.
What should we retain? The water supply is exposed to a pulsated magnetic field. The oscillatory effect of the magnetic field will eventually break the solvation spheres that surround the calcium and bicarbonate ions. Free from the solvation spheres, the calcium ions positive and the bicarbonate ions negative will attract each other and will form calcium carbonate. The anti-scaling effect is produced by the fact that the crystallization is undertaken without support, and the limescale microcrystals formed will not encrust. Now we will see and comprehend how Dropson exploits the EMI technology to create an anti-scaling effect.
How does Dropson work? First, the laminar flow of your installation will be transformed into turbulent flow by the action of the Dropson vortex effect. At the same time, an electronic module controls different multi-zone magnetic field generators. These frequency-specific magnetic impacts act directly upon the turbulent water flow. The association of the kinetic energy of the vortex with the magnetic impacts generates the crystallization of the calcium and carbonate ions suspended in the water before they enter your installation. Treatment with Dropson has two effects. The prevention effect. These limescale microcrystals have a homogeneous form and structure that prevents encrusting. They cannot set on any surface, as they are already crystallized. They will cross through the installation without setting on either pipes or household appliances. The microcrystals generated float in the water and are flashed out.
What should we retain? EMI technology combines two actions, the vortex effect. Turbulences are created to debilitate the solvation spheres, as well as the magnetic field effect. These solvation spheres will break down and release the calcium and bicarbonate ions to create non-encrusting microcrystals. As these limescale microcrystals have already crystallized, they will not adhere to any surface. They will travel through the installation and will be flushed out by the taps or outlets. Water treated by electrical or magnetic fields has the characteristic to progressively dissolve existing limescale deposits in the installation. This is the healing effect. Therefore, limescale is insoluble in water, as proven by seashells, mainly made out of limescale. These shells are essentially calcium carbonate, therefore limescale. If limescale were soluble in water, they could not survive. Now we will see a video that explains how the anti-scaling system's healing effect works.
Water treated by physical treatment also has the distinction of progressively dissolving existing lime in the installation. As lime is insoluble in water, one must take interest in the geochemistry of the carbonates to understand the mechanisms responsible for the healing effect. We have seen that the first anti-fouling effect is obtained by the formation of non-fouling microcrystals. As we saw before, these microcrystals were formed by bonding calcium and bicarbonate ions under the action of magnetic impacts. But let us reach back a little and consider the chemical representation of a bicarbonate ion, specifically in the letter H and in its chemical composition. This letter H corresponds to the hydrogen atom that conforms its chemical formula. Now, if we look again at the moment of formation of scale microcrystals, formed by calcium and bicarbonate ions, we see that the bicarbonate loses its hydrogen atom upon crystallizing. This hydrogen freed from this crystallization will combine with other bicarbonate ions present in the water, forming a new molecule. A molecule of bicarbonate that receives a hydrogen atom transforms into carbonic acid. Carbonic acid is a weak acid. This weak acid is capable of dissolving scale if it is in contact long enough. The presence of this weak acid will act on the calcium-carbonic equilibrium and will progressively dissolve the existing lime in the installation. Let us again observe the complete mechanism of the physical treatment. Before treatment, water contains dissolved calcium and bicarbonate ions. The physical treatment acts on these elements and modifies the calcium-carbonic equilibrium. Calcium combines with bicarbonate to form a non-fouling lime crystal. The hydrogen freed from this crystallization combines with another bicarbonate to form a molecule of carbonic acid. After treatment, for each lime crystal formed, a molecule of carbonic acid is also formed. Physical treatment offers two advantages. The Lemma-scale preventive effect that generates non-scaling microcrystals that flow through the installation without adhering to any surface and are flushed down the drain. The curative effect, generated by the carbonic acid molecules capable of dissolving existing scale. This is how the physical treatments work.
What should we retain? The healing effect will initiate from the system outlet. A new molecule of carbonic acid will be formed for each microcrystal limescale molecule created. The carbonic acid molecules will dissolve existing limescale in the installation. We must point out that carbonic acid is a weak acid. It can be found, for example, in fizzy drinks such as Coca-Cola or sparkling water. The healing effect will be made by the water flowing through the installation. Well, we have reached the end of the first part of the Dropson webinar. Here's a brief recap. You now know the physical properties of water. You now know how limescale is formed in hot and cold water. And you comprehend the preventive and healing anti-scaling effect. Thank you. We invite you to continue with the second Dropson webinar module, where we will explore the differences between Dropson technology and the main physical technologies that the market has to offer. See you soon.